Hello, welcome you all for today's class. Myself Vijay Shrikavkar. This portion is from Karnataka University, especially for BSc 5th semester with a paper 1 real analysis and this unit 1 with the Riemann integration. So we'll be seeing with the intervals, partition of a closed intervals, length of the subinterval, norm of a partition and a refinement of a partition in this session. So let us see what is the open interval. So you have already learned in the lower grade classes, that is what is the open interval. So simple steps I have taken here. X lies between A and B, that is only those values which are between A and B, that is excluding A and B. So if I take A as a 2 and B as a 5, we put it the open interval as a bracket, open bracket. That is, an element x belongs to the open bracket 2 and 5. Then closed interval. Closed interval, we write it as x lies between A and B. The symbol is less than or equals to. This represent restricted to B and restricted to A. So we say that which lies between A and B, including A and B. So the difference between open and closed, here the values A and B are excluded, and in this interval the values A and B are included, and we represent as a closed bracket A and B. So I have taken an example as a closed bracket. An element x belongs to the closed interval 2, 5. Next we see what is the semi-open or semi-closed, that is half open and half closed interval. Or we may say that open from left and closed from right, excluding A and including B. Symbolically we represent as x belongs to, this is open at 2 and closed at 5. And represent this as x, this is closed, this symbol represent closed at 5, and this is less than represent it is open at 2. The same way we write it closed at 2 and open at 5. That is closed at left and open at right. The symbolic representation of the real numbers, we write it as x belongs to R, symbol is R. Now what is R? R is in between minus infinity to plus infinity. Suppose if I take x greater than 2, we write it as x belongs to. So it is greater than 2 means what? It is open at 2 and also open till what? Infinity. X less than 2 implies x belongs to minus infinity to 2. X greater than or equals to 2. This is closed at 2 and open at infinity. That is greater than 2 implies it is infinity. Less than or equals to implies open at minus infinity and closed at 2. Now we'll see what is a partition or division of an interval. Let the interval I equals to the closed interval AB be a finite closed interval, and the length, or you may say the interval A to B, closed interval A to B, we have the interval, subinterval, write it as x0, x1, x2, so on, xn. That is x0 is less than x1, so on we continue, it is less than xn. So the last interval or last term, this point represent the last interval value as a B and initial value as a A, or this as the initial value and B as a final value. Then the finite order set P is given by set of those points x0 to xn and is known as partition of the given interval I. That is, what is I? Now I equals to the closed interval AB and is denoted as P of AB. Now P represents partition of the closed interval AB, or we say D of AB. Now D represents division of an interval. So we write D of closed interval AB. So I have put a real line here with a point x1, x2, so on, xm. The initial value represent as A and the end point represent as a B. Segment of a partition. Now what is the segment of a partition is the n closed interval. So I have taken closed interval as A to B. In between A and B we have point x0 to xn. I1 represent the first 2 points x0 to x1 with a closed interval. Next interval is I2. You write it as x2 to x3. In between this we write rth interval as IR as XR minus 1 and a XR, and nth interval as a XN minus 1 and a XN is determined by a P, is a segment of the partition P. Now, length of the subinterval. So, given I equals to AB represent the length of the interval. Now, we'll see what is the length of the subinterval. The length of the subinterval IR. Here IR is equal to XR minus 1 and XR. So, IR or the rth segment is denoted by delta R, or you can represent this symbol. Now, what is delta R? Delta R equals to the difference between this term, that is XR minus XR minus 1. As we write, I is equal to AB, the length of the interval as B minus A. Here B as XR and A as a XR minus 1. So, length of the subinterval delta R is given by XR minus XR minus 1, where R is from 1 to n. Norm of a partition. The length of the greatest of all the intervals. So we learned what is the length of the interval. So we collect the greatest of all the intervals IR of a partition P is known as its norm of P and is denoted as parallel. This symbol P or mu of P. Now mu of P is given by maximum, that is greatest of all the intervals. Maximum of delta R, where R lies between 1 and n. Or you write maximum of, now delta R represented by the length of the subinterval XR minus XR minus 1, where R is from 1 to n. We will see what is the refinement of a partition. If P1 and P2 represent the partition of the interval AB such that P2 is greater than P1. So those two are a partition of the given interval AB. That is, every point of the partition P1 in as well as a point P2, we shall say that P2 is finer than P1, or we may say that P2 is refinement of a P1 if P2 is greater than P1. This symbol represents P2 is finer than P1. The second point, if P1 and P2 are two partitions of a closed interval AB, then their union, that is P1 union P2, is known as common refinement of those two partitions P1 and P2. So, I have referred to cover this topic. The references for this topic as Real Analysis by Deepak Chatterjee, Real Analysis by N.P. Bali, Real Analysis by Shanti Narayan and M.D. Rai Singhani. I think you are clear with this concept. Thank you for watching this video.